All right, so today we're doing the mapping a water table lab. Mapping a water table lab. And with that lab, in your packet was tracing paper. So you're gonna need a piece of tracing paper as well. If you don't have tracing paper, which you should have in your packet, you could probably get by with regular paper, but tracing paper would be better. All right, so remember what happens when water soaks in the ground. Water soaks in the ground and it goes downward until it eventually hits solid rock, impermeable rock. And from that point, the water starts to build up. And down here in the zone of saturation, this is where all the pore spaces are filled with water. Up here, the zone of aeration, that's where all the pore spaces are still filled with air, and the boundary between them right there is the water table. All right, so kind of looks like this guy right here. The bottom of the beaker would be the impermeable rock. That layer right there where all the pore spaces are filled with water is the zone of saturation. Up here, the zone of aeration, and that would be the water table right there. Now, the water table, for the most part, but not always, a lot of times has a similar shape to the land above it. So here's the land above it, all right, and here's the shape of the water table. So it somewhat follows the shape of the land, but not exactly. Now, if there's a hole over here or a valley, what happens? Well, water underground kind of flows a lot like water above ground, because water, if I spilled water right there, it would run off that way, go downhill. Well, the same idea with water in the ground, water underground flows downhill too. So like, since this area here is higher than this area here, the water would flow this way. Very slowly, mind you, but the water underground would flow this way, all right? And then where I have a hole here, this hole, if it cuts down into the water table, that would fill up with water. And if instead of being a hole that was a valley, then the water from the ground would flow into that stream, and then the stream would take the water away. So where there's a stream, that's a spot where the water table is at the surface. All right. Now, sometimes there might be a spot like over here where the water table is at the surface, and that would be a spot where the water would come out of the ground right there. And since this part of the water table here is higher than that part of the water table there, there'd be a certain amount of pressure pushing down, which would cause the water to kind of squirt up there, and that would be a spring. Right? So right here would be a spot where the water table reaches the surface, and there's pressure behind it, so the water would kind of gush out. That would be a spring. All right? And you can make man-made springs if you drill in just the right area where there's a certain amount of water pressure, the water will come up. Those are called artesian wells, but basically it's a man-made spring. All right, now how you get a well? How you get a well would be like if I drilled a hole right there, all right? I drilled a hole right there, and then that hole would fill up with water to the level of the water table. Right? And or if over here, I drilled a hole right there. I drilled a hole right there. That hole would fill up with water to the level of the water table. Now, sometimes you might want to know what the shape of the water table is underneath the surface of the land. All right, and an example where you might want to know that is, let's say there was someone had a chemical tank here. They had a tank of some sort of chemical right there, and that tank started leaking. All right, the tank started leaking, and those chemicals were getting into the water table. All right. And what I needed to know is what wells would most likely be contaminated by that pollutant, all right? Because like right, if the contamination's right here, the water flow is going to go that way because that way is downhill. So what would likely happen is these chemicals would contaminate that well, but they probably wouldn't contaminate this one because it's kind of upstream from where the chemicals are. All right. But to know that, you'd have to know what the shape of the water table is. Because again, the water table a lot of time is similar to the shape of the land above it, but not always. Like over here, there's a big lump right there, but underneath here, there's just like a minor lump. So the surface features don't always, match up with the water table. A lot of times they're similar, but they're not exactly the same. So you might want to know what the shape of the water table is underneath the surface, so you know what direction this chemical is going to go. All right. Now, how do you go about doing that? Well, you need a bunch of data points. And how I could go about making the data points is, well, one way of doing it is I could drill a whole bunch of wells, and then from that I could figure out the elevation of the water table at various points. The problem with doing that is drilling wells is very expensive. Right? So while it's a possible way of doing it, it's not a feasible one because of the price. So there's a much easier way to map out the water table, or what the shape of the water table is underneath the Earth's surface. And all you really need for that is a topographic map. And that's what we're going to be doing today, is you're going to have to draw a water table from the information on a contour map. And it's actually, once you know how to do it, it's pretty easy to do. All right, so how do you go about doing it? All right, so let's say here's a contour map of an area, and what I want to do is I want to make a map of the water table underneath the ground. All right. Now, a few things to remember on contour maps is that on the contour maps, where the lines are closer together, that means the land's steeper. But another thing that we mentioned with contour maps is that wherever a stream crosses a contour line, that causes there to be a little V's in the contour lines. It causes there to be little V's in the contour lines. Now, the reason why those little V's exist is because the stream erodes the land back. And actually what happens is it erodes the land back basically to the level of the water table. Right? So any place where that stream crosses that contour line, like that spot right there, that's actually usually the level of the water table at that point. Right? So what we're going to be concerned about is any spot where the streams cross the contour lines. Right? Now, before we do that, what we probably want to do is we probably want to label our contour lines, the values of them. Now remember that usually every fifth contour line is labeled. So there's 100, there's 150. So that'd be 100 and 150. The line, that would make the lines going by 110, 120, 130, 140, 150, 160. That's telling you the contour interval's 10. So I think it's easier if you label the values on the contour map. All right, so there's 100, this would be 110, 120, 130, 140, 150, 160, and that would be 90 right there. All right, next thing I want to do is I want to take my tracing paper. I want to take my tracing paper, and I'm going to put my tracing paper over the map. I'm going to put my tracing paper over the map like this. And what I want to do is I want to trace the outline of the map as such. So this is the map area right here. This is the map area right here. Next off, all right, what I'm concerned about is any spot where the stream crosses the contour line, all right? So like right there, the stream's crossing the contour line, so I'm making a data point. Right there, I'm making a data point. Right there, I'm making a data point. Right there, I'm making a data point. So wherever the stream crosses the iso lines, the contour lines. So right there, 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 right there. All right, next, what I want to do is I want to label the values of each of those points. So right there, that's on the 150 line. This here's on the 150 line. Right here's on the 140 line. That's on the 140 line. That's on the 140 line. That point right there is on the 130 line. That's on the 130 line. That's on the 130 line. This point right here is on the 120 line. That's on the 120 line. That's on the 120 line. This right here is the 110 line. The 110 line. The 110 line. Right here's on the 100 line. Right here's the 100 line. Right there's the 100 line. And that's on the 90 line. And that's on the 90 line. All right, so what these data points are, where the stream crosses the contour line, these are spots where the water table reaches the surface. All right, so now I don't need that part anymore. What I have right here is all the data I need to draw a map of the water table. All right, so I want to follow my regular rules for drawing iso lines. Remember that when I draw iso lines, the lines can't stop in the middle of the map. They either have to circle up or go up the sides of the map. Remember that my iso lines, if I'm drawing a 140 line, the only thing that can be on that line are values that are exactly 140. The other thing is when I'm drawing my lines, I have to make sure the lines don't cross. If my lines cross, I know I made a mistake someplace. All right, so on my map here, I either want to find the highest value and work down or the lowest value and work up. So let's say I'm going to do the highest value and work down. There's 150, there's 150, and I can't just let them die there, so they're going to go off the side of the map like this. All right. Next, 140, 140, 140, and it goes off the side of the map like that. There's 130, 130, 130, all right, and then I go off the side of the map like that. There's 120, 120, 120, 120, 110, 110, 110, 110. There's 100, 100, 100, 100. And then here's 90 and 90 like that. All right, so what I have right here, this is a contour map of the water table that is beneath this area. So this right here is a contour map of what the shape of the land is like, and then down here is a contour map of what the shape of the water table is underneath it. And that way, I could make, if I was trying to drill a well like right here, I know that I'd probably have to drill down to like 125 meters down to get to that spot right there. If I wanted to drill a well over here, I know that I'd probably have to drill down to like 145 meters to get there, in elevation to get there. All right, so that's what this is right here. And again, it's a very important thing if you're trying to track like pollutants that are flowing in the ground, or if you want to just drill wells, things like that. That's why you'd want to have a water table map. All right, so that's how you do it. Once you have your water table map done, then you just answer the questions with it. So this, if you probably noticed, is not the one that you're actually, this was an example. This is not the one you're actually doing in the lab. The one that you're actually doing in the lab is this one right here, but how you go about making it, this one's a little more complicated than the one I did, but how you go about making it the same way. So you put the tracing paper over here, you trace the outline of the map, and then on the tracing paper, wherever a contour line crosses that, wherever a stream crosses the contour line, you're going to plot those points on the tracing paper, then write the values, and then draw the lines. All right. So you have once you get the water table map of this area done, then you answer the questions and so forth. All right, but that's it.